Picture this: you're floating in the infinite blackness of space, surrounded by a silence so deep it hums in your bones. Out here, the universe doesn't play by the rules we know. It's a place where reality twists into shapes we can barely comprehend, where objects so strange they seem ripped from science fiction drift unnoticed until some sharp-eyed astronomer catches a glimpse. And when they do, it shatters everything we thought we understood. That's the magic of space. It's the last great frontier, a cosmic cabinet of curiosities waiting to be opened. Today, we're diving into that cabinet, not for the usual suspects, not for black holes or supernovas, though those are plenty mysterious. No, we're hunting for the outliers, the cosmic oddballs that make even seasoned scientists scratch their heads. Think rogue planets with oceans of lava, stars that flicker like someone's flipping a switch, or structures so enormous they shouldn't exist. We've scoured the depths of discovery to bring you 25 of the strangest objects ever spotted in the void, each one a puzzle begging to be solved. What makes these finds so thrilling isn't just their weirdness. It's what they reveal about the universe's endless creativity. Every bizarre discovery forces us to rethink the boundaries of physics, chemistry, even time itself. And behind each one, a story of accidental breakthroughs, heart-stopping wait, what moments, and the sheer stubbornness of humans staring into the dark and refusing to look away. So buckle up. By the time we're done, you'll see the cosmos not as a static painting, but as a living, breathing enigma, one that's far stranger and far more wonderful than we ever imagined. It starts with a shadow, an object drifting silently against the backdrop of stars, spotted not by some high-tech satellite but by a lone radio operator in the 1920s. That's the origin story of the Black Knight, a supposed alien satellite that's become the stuff of interstellar legend. For decades, conspiracy theorists have claimed this mysterious object has been orbiting Earth for thousands of years, sending out strange signals no one can decipher. Some say it's an extraterrestrial probe watching us. Others insist it's a relic from an ancient, advanced civilization. Even today, the myth persists, fueled by grainy images and eerie radio transmissions that sound like something straight out of a science fiction movie. But here's where things get even weirder. The Black Knight doesn't just exist in hushed whispers, it's left actual breadcrumbs. In 1954, newspapers reported that the U.S. Air Force had detected two unusual objects in polar orbit, a feat human technology supposedly couldn't achieve yet. Then, in 1960, a strange, dark mass was photographed during early space missions, its jagged edges looking nothing like the smooth, manufactured satellites of the time. The images spread like wildfire, with believers pointing to its unnatural shape as proof of otherworldly origins. And the signals, reports of unexplained radio pulses dating back to Nikola Tesla's experiments, only deepened the mystery. Yet for every chilling detail, science has pushed back. NASA has dismissed the Black Knight as space debris, maybe a thermal blanket lost during a mission or a discarded piece of a satellite. Skeptics argue the infamous photos show nothing more than shadows or camera artifacts. Even the radio signals have been explained as natural cosmic noise or human-made interference. But try telling that to the die-hard believers. The Black Knight thrives in that gray area between fact and folklore, a Rorschach test for our fascination with the unknown. What's fascinating isn't just the object itself, but what it represents. The Black Knight taps into something primal, the fear or hope that we're not alone. Its mythos borrows from our love of stories, blending bits of real science with the irresistible allure of a cosmic whodunit. Whether it's space junk or something far stranger, one thing's certain: the legend isn't going anywhere. And in a universe full of mysteries, sometimes the most compelling ones are the ones we create ourselves. Now imagine an object streaking through our solar system, not from here, but from somewhere beyond, somewhere so distant we can only guess at its origins. That's Oumuamua, the first confirmed interstellar visitor ever detected, and it defies nearly every expectation we have about cosmic travelers. Discovered in 2017 by astronomers in Hawaii, its name means scout or messenger from afar, and it lived up to that title by delivering one mystery after another. First, there's its shape, long and narrow, like a cosmic cigar tumbling end over end through space. Most asteroids or comets we've observed are lumpy or round, but Oumuamua stretched nearly a quarter of a mile in length while being just 1/10 as wide. This bizarre geometry alone set astronomers abuzz, prompting questions about how such an object could form naturally. Then came the real curveball: it accelerated. Unlike typical comets, which speed up when their icy surfaces vaporize in sunlight, Oumuamua had no visible tail or coma, no obvious explanation for its sudden burst of speed. It was as if something unseen was pushing it forward. That's where the controversy erupted. Harvard astrophysicist Avi Loeb made headlines by suggesting the unthinkable. Could Oumuamua be artificial? His theory, dismissed by many but embraced by a vocal few, proposed that the object's acceleration might be explained by a light sail, a thin, reflective structure propelled by starlight, potentially of alien origin. Loeb pointed to Oumuamua's unusual brightness variations and its trajectory, which didn't quite match natural models. Skeptics, of course, countered with alternative explanations. Maybe it was a rare type of hydrogen iceberg or a fragment of a shattered planet, its odd properties the result of eons spent adrift in interstellar space. What makes Oumuamua so captivating isn't just the debate, it's the reminder of how little we truly know. Here was an object that passed through our cosmic neighborhood, offered us a fleeting glimpse, and then vanished forever into the void, leaving behind more questions than answers. Was it a comet, an asteroid, or something else entirely? The truth might remain out of reach, but Oumuamua's brief visit shook our assumptions, proving that even in our own backyard, the universe has surprises we're only beginning to imagine. Every astronomer dreams of that moment, the split second when the universe seems to wink at you, offering a clue it normally keeps hidden. That's exactly what happened on August 15, 1977, when a radio telescope in Ohio picked up a signal so extraordinary. It was circled in red ink and labeled with a single, breathless word: wow. The story begins with Ohio State University's Big Ear Telescope, a modest setup scanning the skies for signs of extraterrestrial intelligence. For years, it listened to the cosmic static, the white noise of the universe, until that summer night when the needle jumped. For 72 seconds, a burst of radio waves blared from the constellation Sagittarius, pulsing at exactly the frequency scientists had predicted an alien transmission might use: 1420 MHz, a quiet band where hydrogen, the universe's most abundant element, naturally resonates. The signal was 30 times louder than background noise, narrow and focused unlike anything natural they'd ever heard. And then, just as suddenly as it appeared, it vanished, never to repeat. The astronomer who spotted it, Jerry Amon, was so stunned he scrawled, "Wow," right on the printout, giving the signal its immortal name. But the real mystery: despite decades of searching, no one's ever found it again. Not a whisper, not an echo. It's as if the universe handed us a single, perfect puzzle piece, then hid the rest of the box. Skeptics have tried to explain it away. Some say it was a passing comet, though none were in the area at the time. Others suggest a secret military transmission or a glitch, but no human technology matched the signal's unique properties. The most tantalizing theory, that it was a fleeting message from another civilization, a cosmic hello that swept past us before we could reply. What makes the wow signal so haunting isn't just the unanswered question of its origin, it's the way it mirrors our own loneliness. In a galaxy teeming with stars, we're still listening for a voice that might never speak again. And whether it was aliens, a quirk of physics, or something else entirely, that 72-second burst remains astronomy's most tantalizing maybe. Stars don't just flicker, not like this. At least, that's what astronomers thought until they stumbled upon KIC 8462852, better known as Tabby's star. Named after the scientist who first sounded the alarm, Tabitha Boyajian, this star behaves like nothing else in the cosmos. Imagine a light bulb that dims unpredictably, sometimes just a little, other times by a staggering 22%, as if something colossal is passing in front of it. And that's exactly what had researchers scrambling for answers, sparking theories so wild they blurred the line between science and sci-fi. When Tabby's star's odd behavior was first spotted by NASA's Kepler telescope, the initial assumption was simple: maybe it was just a swarm of comets. But comets couldn't explain the sheer scale of the dimming, or the fact that the star's light didn't dip in the smooth, symmetrical way you'd expect from orbiting debris. That's when the whispers began. Could this be evidence of a Dyson sphere, a hypothetical alien megastructure designed to harvest a star's energy? The idea wasn't entirely fringe. After all, the dimming patterns resembled what you might see if an advanced civilization had built a massive, uneven swarm of solar collectors around their sun. Even famed physicist Freeman Dyson had once theorized such structures might exist, though he never expected us to find one so soon. Of course, extraordinary claims demand extraordinary proof. Follow-up studies pointed to a more mundane culprit: dust, lots of it. Observations revealed that the star's light dimmed more at certain wavelengths, consistent with fine particles scattering its glow rather than solid megastructures blocking it. Some scientists proposed a catastrophic collision between planets, leaving behind a vast, swirling debris field. Others suggested the star might be ingesting a moon or even an entire planet, creating temporary clouds of vaporized rock. Yet the mystery refuses to die. Dust might explain some of the dimming, but not all of it, especially not the century-long fade noted in historical records, where Tabby's star appears to have lost brightness steadily over time. And why does the dust behave so erratically with no clear orbital pattern? Every answer seems to raise new questions, leaving the door cracked open for those who still wonder, what if we're not just seeing dust? What if we're glimpsing something far stranger? Tabby's star is more than an astronomical oddity. It's a humbling reminder of how much we still don't understand. Whether the truth lies in cosmic dust or something beyond our current imagination, one thing's certain: the universe loves keeping us guessing. And sometimes the most tantalizing mysteries aren't the ones we solve, but the ones that refuse to let us go. Deep within the heart of our galaxy, hidden from human eyes for millennia, lies a pair of colossal structures so vast they defy comprehension: the Fermi Bubbles. Picture two enormous balloons of superheated gas, each stretching 25,000 light-years into space, erupting from the Milky Way's core like a cosmic hourglass. These invisible titans, named after the Fermi Gamma-ray Space Telescope that discovered them in 2010, glow with high-energy gamma rays, painting the sky with a faint but unmistakable signature of something extraordinary. What makes these bubbles so baffling isn't just their size, it's what's powering them. Normal stellar processes can't explain the sheer energy rippling through these structures. The leading theory: a cataclysmic eruption from the supermassive black hole at our galaxy's center, Sagittarius A star. Imagine a belch of cosmic proportions, a jet of energy so violent it punched through the dense gas of the galactic center, carving out these caverns of radiation. Based on the bubble's current expansion rate, astronomers estimate this event could have happened anywhere between 2 and 4 million years ago, a blink in cosmic time. But here's where things get even stranger. Not everyone's convinced a black hole outburst is solely to blame. Some researchers point to a frenzy of star formation in the galactic core, where countless massive stars lived fast, died young, and exploded as supernova in rapid succession. That collective fury could have heated the surrounding gas to extreme temperatures, creating the conditions for these bubbles to form. Others speculate about more exotic possibilities, like dark matter annihilations or even echoes of a long-lost collision with a dwarf galaxy. The Fermi bubbles aren't just a scientific curiosity, they're a window into our galaxy's violent past. Their very existence suggests the Milky Way isn't the quiet, stable neighborhood we once imagined. Lurking beneath its serene spiral arms is a history of chaos, of explosions powerful enough to reshape the fabric of space around us. And as telescopes grow sharper, these faint gamma-ray ghosts may yet reveal secrets about the forces that sculpt galaxies and whether our own cosmic home is due for another eruption. One thing's certain, the universe never fails to remind us that even in our own backyard, the ordinary is anything but. The Fermi bubbles stand as silent monuments to the galaxy's untamed energy, a whisper from the past that challenges everything we thought we knew about the place we call home. Out in the cosmic deep, where galaxies drift like leaves on a river, there's a tug-of-war happening on a scale so vast it bends the mind. On one side, the Great Attractor, a gravitational monster lurking in the darkness, pulling thousands of galaxies, including our own Milky Way, toward it at over 2 million kilometers per hour. On the other, the dipole repeller, a yawning void so empty, it acts like a cosmic repellent, pushing galaxies away with the sheer force of its nothingness. Together, they're rewriting the rules of how we think the universe moves. Let's start with the Great Attractor because its story is the stuff of scientific detective work. Hidden behind the thick dust of our galaxy's central plane, this invisible gravitational heavyweight was first suspected in the 1970s when astronomers noticed something odd. Every galaxy in our local supercluster, including Andromeda and the Milky Way, was drifting toward the same patch of sky near the constellation Centaurus. The problem, when they pointed telescopes there, they found nothing, or at least nothing visible. It wasn't until the 21st century, with X-ray and radio telescopes piercing through the cosmic dust, that the truth emerged. A dense knot of galaxies, each packed with dark matter, collectively exerting a pull so strong it dominates the motion of everything around it. Think of it like a whirlpool in an ocean current, dragging entire islands of stars toward its center. But here's the twist: the Great Attractor isn't the end of the journey. Like a matryoshka doll of gravity, it's just one piece of an even larger puzzle. Behind it lies the Shapley supercluster, an even more massive congregation of galaxies pulling the Great Attractor itself. It's a cosmic chain of command, with gravity calling the shots across hundreds of millions of light years. Now flip the script. While the Great Attractor pulls, the dipole repeller pushes a vast, near-empty region of space so devoid of matter that it creates a kind of negative gravity. Discovered in 2017, this cosmic anti-attractor explains why galaxies aren't just streaming toward the Great Attractor in a straight line. Instead, they're being repelled by this enormous void, as if space itself were a rubber sheet dented by heavy weights and stretched thin by gaps. Picture a ball rolling downhill, but the hill isn't just steep, it's got a giant hole on one side, warping the ball's path in unexpected ways. The beauty of these two phenomena isn't just their scale, it's what they reveal about the universe's hidden scaffolding. For centuries, we assumed cosmic motion was driven by what we could see: stars, galaxies, nebulae. But the Great Attractor and dipole repeller prove that the real architects are the things we can't see: dark matter, dark energy, and the eerie voids between galaxies. They're the invisible hands shaping the grand flow of the cosmos, reminding us that even the emptiest spaces have weight, and the darkest corners hold the keys to motion itself. So the next time you look up at the night sky, remember, we're not just floating aimlessly. We're caught in a celestial dance, pulled by forces we're only beginning to map, pushed by absences we're only starting to understand. And somewhere out there, in the spaces between the light, the universe is still writing the rules. Some galaxies look like whirlpools, others like fuzzy cotton balls, but Hoag's object. It looks like someone took a cosmic cookie cutter to the stars. This bizarre ring galaxy, discovered by astronomer Art Hoag in 1950, is so perfectly symmetrical it seems artificial. At its heart sits a dense golden core of aging stars glowing like a celestial ember. Surrounding it, a flawless sapphire blue ring of younger stars sparkling with newborn clusters and nebulae. And between them, nothing. A starless chasm so vast and empty it defies everything we know about how galaxies form. The first mystery is that gap, a yawning 12,000 light-year void separating the core from the ring. Normally, galaxies don't just stop. Stars trail off gradually, thinning into the darkness. But Hoag's object treats physics like a suggestion, presenting us with a cosmic bullseye that shouldn't exist. How did this happen? One theory points to a galactic collision, an ancient smash-up where a smaller galaxy plowed through the center of a larger one, sending shockwaves rippling outward. Those waves could have compressed gas along the edges, triggering star formation in a ring while leaving the core untouched. It's like tossing a pebble into a pond and watching the ripples crystallize into stars. But here's the twist: there's no sign of a culprit, no mangled galaxy remnants, no debris trail, just this pristine, isolated ring floating in space as if it's always been this way. That's led some researchers to propose an even wilder idea: instability. Maybe the original galaxy's rotation became so unstable over billions of years that stars and gas naturally migrated into separate zones, like cream separating from milk. Others suggest a phenomenon called resonance, where gravitational forces from the core sculpted the outer disk into this perfect loop over eons. The weirdness doesn't stop there. Peering deeper into the emptiness, astronomers found something even more perplexing: another, fainter ring nestled between the core and the main one. It's as if the universe built this thing in layers, each more baffling than the last. And floating far beyond the ring, another, smaller ring galaxy, perfectly aligned in the background. A cosmic echo that makes you wonder, is this a fluke or a clue? Hoag's object doesn't just challenge our ideas about galaxy formation, it taunts them. In a universe where chaos reigns, this unnatural perfection stands as a quiet rebellion, proving that sometimes the most ordinary-looking corners of space hide the deepest puzzles. Whether it's the ghost of a collision, a quirk of gravity, or something else entirely, one thing's clear: the universe has a flair for the dramatic, and Hoag's object. It's its masterpiece. Most nebulae swirl like spilled paint across the cosmos, amorphous and chaotic, all delicate tendrils and wispy clouds. Then there's the red rectangle, a cosmic structure so precise it looks like it was sketched with a ruler. Nestled 2,300 light-years away in the constellation Monoceros, this glowing crimson enigma defies every expectation of what a nebula should be. Its sharp, geometric form, two cones of vibrant gas meeting at a central star like an hourglass carved from rubies, has left astronomers staring in disbelief since its discovery in the 1970s. At the heart of this spectacle lies a dying star, HD 44179, in its final act of celestial performance. Unlike the explosive deaths of massive stars, this one is quieter, shedding its outer layers in a slow, elegant ballet. But here's the twist: instead of scattering randomly, the expelled gas and dust have arranged themselves into this impossible X shape, with ladder-like rungs of glowing material stretching between the cones. It's as if the star is exhaling smoke rings, each one perfectly aligned, each one defying the entropy that governs the universe, the secret to this unnatural symmetry. A thick disk of dust encircling the star's equator like a cosmic hula hoop. As the star's winds blow material outward, this disk funnels the flow into two opposing jets, sculpting the nebula's sharp edges. The crimson hue comes from an even rarer ingredient, a type of organic molecule called polycyclic aromatic hydrocarbons, or PAH. These carbon-rich compounds glow red when bombarded by the star's ultraviolet light, painting the structure in shades that earned it its name. But the red rectangle isn't just a cosmic oddity, it's a time capsule. The precise alignment of its rungs suggests the star's mass loss occurs in pulses, with each new eruption adding another step to the ladder. Some scientists believe we're witnessing the birth of a future planetary nebula, a phase so brief in stellar evolution that catching one mid-formation is like finding a butterfly still half-trapped in its chrysalis. Others speculate the central star might actually be a binary pair, their orbital dance further sculpting the outflow into these razor-sharp shapes. What's most humbling about the red rectangle isn't just its beauty, it's the reminder that even in death, stars can create order from chaos. Against the dark canvas of space, this fiery geometry stands as a testament to the universe's hidden blueprints, proving that sometimes the most breathtaking art isn't found in the splashy supernovas or swirling galaxies, but in the quiet, meticulous precision of a star's final whisper. Imagine the entire universe in motion, not just stars drifting or galaxies spinning, but whole clusters of them, hundreds of millions of light-years wide, all streaming in the same direction like leaves caught in a cosmic river. This isn't science fiction, it's the dark flow, one of the most perplexing discoveries in modern cosmology. First detected in 2008 by NASA, a Wilkinson microwave anisotropy probe, this mysterious phenomenon suggests something massive, something beyond the edges of everything we can see, is tugging at the fabric of space itself. The story begins with the cosmic microwave background, the faint afterglow of the Big Bang that blankets the sky. Scientists use it like a map, studying tiny temperature fluctuations to trace the motion of galaxy clusters. But when researchers analyzed the data, they found something impossible. Hundreds of clusters were moving at breakneck speeds toward a single patch of space near the constellations Centaurus and Vela. Not just drifting, not just meandering, but hurtling at speeds exceeding 2 million miles per hour, all in unison. The kicker, there's nothing there. No supercluster, no dense knot of matter, no known source of gravity powerful enough to explain it. Just an eerie, invisible pull from beyond the horizon of the observable universe. Skeptics were quick to challenge the findings. Could this just be a measurement error, a glitch in the data? But follow-up studies, including observations from the Planck satellite, only deepened the mystery. The dark flow persisted, stretching farther than expected, billions of light-years beyond where any known structure should exist. That's when the theories took a turn for the extraordinary. Some cosmologists suggested we might be seeing the gravitational influence of another universe, a neighboring bubble of space-time brushing against our own in the vast multiverse. Others proposed that the Big Bang wasn't perfectly symmetrical, leaving behind wrinkles in the fabric of reality that still tug matter in one direction. Then there's the most unsettling possibility, that the dark flow is evidence of something even more fundamental we've gotten wrong about the universe. Our entire understanding of cosmology rests on the assumption that the cosmos is isotropic, that it looks roughly the same in all directions. But if galaxy clusters are being yanked toward some unseen attractor, that principle crumbles. It would mean the universe isn't just lopsided, it's oriented toward something we can't see, can't measure, and might never fully comprehend. What makes the dark flow so electrifying isn't just the science, it's the existential vertigo it induces. For centuries, we've gazed at the stars and assumed we were at the center of nothing, adrift in a boundless, directionless expanse. But the dark flow hints at a cosmos with landmarks beyond our vision, a universe that doesn't just expand uniformly but flows like a river toward some distant shore. Whether it's a statistical anomaly, a new frontier of physics, or a window into realms beyond our own, one thing's certain: the dark flow reminds us that the universe's greatest mysteries might not lie in the stars we see, but in the darkness we don't. Most galaxies grow quietly, birthing stars from their own gas reserves, but Messier 87 doesn't play by those rules. This cosmic titan, sitting 55 million light-years away in the Virgo cluster, has earned a far darker reputation, the Cannibal Galaxy. And the nickname isn't just for show. Hubble images reveal ghostly trails of stars twisted like cosmic taffy, stretching far beyond the galaxy's glowing core, the aftermath of a feast. These are the remains of smaller galaxies torn apart by M87's relentless gravity, their stars digested into the monster's glowing halo. What makes this galaxy's appetite so staggering is the scale. Over billions of years, M87 has consumed entire galaxies, some as massive as our own Milky Way, leaving behind nothing but these stellar fingerprints. But the real showstopper lies at its heart, a supermassive black hole weighing 6.5 billion times our Sun's mass, the first ever directly imaged in 2019. This beast doesn't just lurk in darkness, it erupts. A jet of plasma stretching 5,000 light-years into space screams outward at nearly light speed, powered by the black hole's insatiable spin. It's a cosmic fire hose, twisting magnetic fields so violently that particles are launched across intergalactic space. The eerie part, this cycle of destruction and creation might be the universe's way of building giants. Galactic cannibalism isn't rare. Our own Milky Way has absorbed smaller galaxies, but M87 takes it to extremes. Each merger fuels its central black hole, which in turn heats surrounding gas, shutting down star formation in its core while the outer regions keep feasting. It's a self-perpetuating machine. The more it eats, the more it grows, and the more it grows, the more it can eat. Yet for all its violence, M87 holds clues to a delicate balance. Those mesmerizing jets, they're recycling energy back into the cosmos, seeding future star formation far beyond the galaxy's grasp. Even as it devours, it gives back, proving that in the grand tapestry of the universe, death and rebirth are threads woven together. So while its hunger might seem monstrous, M87 isn't just a destroyer, it's a sculptor, shaping the universe one meal at a time. Some corners of the universe feel too empty, not just quiet but hollowed out, as if something came through and erased entire chapters of cosmic history. That's the Boötes Void, a spherical abyss so staggeringly large it could swallow thousands of Milky Ways whole, yet contains almost nothing. Astronomers call it the Great Nothing, and for good reason. Stretching 330 million light-years across, this void holds just 60 galaxies where there should be thousands. Step back far enough, and it looks like a puncture wound in the fabric of the cosmos, a place where the universe forgot to fill in the blanks. The mystery isn't just its size, it's how it exists at all. According to our best cosmological models, matter in the universe should distribute roughly evenly, like dough with raisins scattered throughout. The Big Bang's afterglow supports this. Tiny fluctuations in the cosmic microwave background suggest where galaxies should have clumped together, but the Boötes Void defies those blueprints. It's not just a gap, it's a chasm deeper than any simulation predicts, as if entire swaths of galaxies vanished without a trace. So what could carve out such a void? One theory points to dark energy, the mysterious force accelerating the universe's expansion. Maybe, in this region, dark energy worked overtime, pushing matter apart before galaxies could form. Others speculate about an ancient collision between bubble-like regions of space-time during the universe's inflationary phase, a cosmic bruise left behind when two expanding pockets of reality brushed against each other. Then there's the unsettling fringe idea. Could it be evidence of an advanced civilization, one that harnessed the energy of entire galaxies, leaving behind this barren footprint? But the most plausible explanation might be the simplest probability. Even in a fair game of dice, you'll occasionally roll snake eyes. The Boötes Void could just be the universe's unluckiest region, a statistical fluke where matter never quite coalesced. Yet even that answer feels unsatisfying when you consider the void's shape, not a random scattering of emptiness, but a near-perfect sphere, as if something deliberate happened here. What makes the Boötes void so chilling isn't the absence of light, but the absence of answers. It forces us to confront how little we understand about the universe's scaffolding, about why some places teem with galaxies while others stretch into oblivion. And lurking behind every theory is the same unnerving question: is this emptiness an accident, or a sign of something we haven't even begun to imagine? Dead stars aren't supposed to have planets, at least. That's what astronomers believed until 1992, when the universe delivered a cosmic curveball. A distant, rapidly spinning corpse of a star known as PSRB 1257+12 was caught red-handed with not one but 3 worlds orbiting it. These weren't just any planets, they were the first exoplanets ever discovered, survivors of one of the most violent events in the cosmos, dancing around the stellar equivalent of a radioactive lighthouse. Let's start with the pulsar itself, a neutron star so dense a teaspoon of its material would weigh 1 billion tons. It spins at a dizzying 161 times per second, blasting twin beams of radiation into space like a celestial strobe light. This isn't just a dead star, it's the aftermath of a supernova so catastrophic it should have vaporized anything nearby. Yet somehow, against all odds, these planets endured. The mystery lies in how they got there. One theory suggests they're the scorched remnants of the original system, worlds that somehow clung to existence as their star exploded, their surfaces likely scoured to bare rock by the blast. Another possibility, they're second-generation worlds formed from the debris of the supernova itself, cosmic phoenixes rising from the ashes. The pulsar's intense radiation would have crushed nearby dust and gas into dense clumps, forging new planets in an environment more hostile than a blast furnace. But the real shocker is what these worlds might look like. Bathed in constant, lethal radiation, their surfaces could be literal diamonds, crystallized carbon forged under extreme pressure. Others might be iron-heavy husks, their outer layers vaporized long ago, leaving behind metallic cores that glow under the pulsar's relentless glare. There's even a chance one of them is a hellish water world, its oceans locked under miles of superheated steam, trapped between boiling and freezing by the pulsar's erratic heat. What makes these pulsar planets so extraordinary isn't just their resilience, it's the questions they force us to ask. If life could cling to existence here, in the most unforgiving corner of the universe, where else might it be hiding? These worlds are more than curiosities. They're testaments to the universe's stubborn creativity, proving that even in death, stars can give birth to the unimaginable. Imagine a world where the ground beneath your feet isn't rock or sand but diamond, not just scattered gems but a planet-sized jewel glittering in the eternal darkness of space. That's 55 Cancri E, a super-Earth so rich in carbon, scientists suspect much of its mass could be crystallized into one colossal diamond. Twice Earth's size and 8 times its weight, this exotic world orbits so close to its star that a single year lasts just 18 hours, and its surface temperatures soar above 2,000 degrees Celsius, hot enough to melt steel, yet somehow perfect for forging the universe's most luxurious catastrophe. The story of 55 Cancri E reads like a cosmic alchemy experiment gone wild. Most rocky planets, including Earth, are built from silicates, oxygen and silicon bound together. But this planet's host star, 55 Cancri, is unusually carbon-rich, meaning the raw materials available during the system's formation were lopsided. Instead of forming a typical rocky world, gravity sculpted something far stranger. A planet where carbon atoms, crushed under immense pressure, may have bonded into diamond structures stretching for thousands of miles. Some models suggest the interior could contain diamond layers dozens of miles thick, with a molten core of carbon so compressed it behaves like liquid metal. But here's where the plot thickens. Not everyone's convinced this world is truly a diamond paradise. Alternative theories propose a surface blanketed in graphite, the soft, gray cousin of diamond, with deeper layers transitioning into something harder under the planet's crushing gravity. There's also the possibility of a volatile atmosphere rich in carbon monoxide or hydrogen cyanide, turning the skies into a toxic haze that shimmers above the diamond crust. Then there's the wild card tidal forces. Locked in a death grip with its star 55 Cancri's interior, might be heated so intensely that its diamond mantle churns like boiling water, creating geological upheavals we can barely imagine. The real puzzle isn't just what this planet's made of, it's how it got there in the first place. Diamond worlds shouldn't be this close to their stars. Carbon-rich planets typically form farther out, where temperatures are cold enough for carbon compounds to solidify. One possibility: this planet wasn't born here at all. Maybe it migrated inward, its original icy layers vaporizing as it plunged toward the star, leaving behind a dense, glittering core. Or perhaps the entire system was once rich in carbon-heavy comets and asteroids, their debris piling up into a planet-sized gemstone. What makes 55 Cancri more than just a celestial curiosity is what it reveals about the universe's creativity. If diamonds can form on this scale, what other impossible worlds might be out there? Planets made of sapphire, oceans of liquid graphite. The discovery forces us to rethink the very ingredients of planet formation, proving that the cosmos doesn't just build worlds, it crafts them with a jeweler's precision, turning extreme environments into showcases of nature's most astonishing artistry. And somewhere in the darkness, a diamond the size of a planet spins endlessly, waiting for the next chapter of its story to be told. In the vast catalogue of cosmic oddities, few discoveries have left astronomers as genuinely stumped as the odd radio circles, ORCs for short. These gargantuan rings of radio emissions, some stretching a mind-bending million light-years across, appeared out of nowhere in telescope data, glowing like spectral halos around distant galaxies. Unlike anything seen before, they don't correspond to visible light, X-rays, or any other known wavelength. They're ghosts in the machine, cosmic echoes with no obvious source, lurking at the edges of our understanding. The mystery began in 2019, when researchers sifting through data from Australia's ASCAP radio telescope spotted 3 perfect circles, each glowing faintly in radio waves. At first, they assumed it was an error, perhaps a glitch or an artifact of telescope calibration. But then more appeared, each one hauntingly symmetrical, some with galaxies at their centers, others floating in empty space like celestial smoke rings. The most baffling part: these structures don't fade over time. They linger unchanging, as if the universe pressed pause on some colossal, invisible explosion. So what could create rings this enormous? Theories range from the plausible to the downright fantastical. One leading idea involves intergalactic shockwaves, colossal bursts of energy from events like merging supermassive black holes, sending ripples through the thin gas between galaxies. These ripples might excite electrons, causing them to emit radio waves as they spiral around magnetic fields. It's like tossing a boulder into a pond, only the pond is the fabric of space itself, and the ripples glow with energy we can barely detect. Then there's the starburst hypothesis. In galaxies where stars form at breakneck speeds, supernova can erupt in waves, blowing bubbles of hot gas into the void. Over millions of years, these bubbles might expand into perfect spheres, their edges visible only in radio waves. It's a tempting explanation, except some ORCs don't have starburst galaxies at their centers, leaving researchers scratching their heads. But the most electrifying theories venture into uncharted territory. Could these rings be the fingerprints of wormholes, tunnels through space-time predicted by Einstein's equations but never observed? Some physicists speculate that the intense gravitational fields near a wormhole's mouth might accelerate particles to extreme speeds, creating a telltale ring of radio emissions. Others float the idea of cosmic strings, hypothetical, thread-like defects in space-time left over from the Big Bang, whose interactions might release bursts of energy in perfect circles. What makes ORCs so thrilling isn't just their strangeness, it's what they represent. Every new image, every fresh observation peels back another layer of the puzzle, proving that even our most advanced telescopes are barely scratching the surface of what's out there. Whether they are shockwaves from unseen cataclysms, echoes of theoretical physics, or something entirely new, one thing's certain: the universe loves a good mystery. And the ORCs, they're its latest enigma, glowing quietly in the dark, daring us to unravel their secrets. Most stars don't get second chances when a supernova detonates. That's supposed to be the final curtain call. But in 2014, astronomers witnessed something that rewrote the rules: a star that refused to die. Dubbed the zombie star, this cosmic anomaly emerged from the ashes of its own destruction, flickering back to life in defiance of every known law of stellar evolution. The stage was set 450 years earlier, when Danish astronomer Tycho Brahe spotted a brilliant new light in the constellation Cassiopeia, a supernova so bright it outshone Venus for weeks. For centuries, that explosion, known as Tycho's supernova, was considered textbook, a white dwarf stealing matter from a companion star until it reached critical mass and detonated in a thermonuclear blast powerful enough to obliterate its entire stellar system. But when the Hubble Space Telescope trained its gaze on the remnant in the 21st century, it found something impossible: a faint, flickering star still clinging to existence at ground zero. Here's what shouldn't have been there. Type 1, a supernova, are supposed to be total annihilation events. The white dwarf at the heart of the explosion is thought to vaporize completely, leaving behind only an expanding cloud of debris. Yet this star wasn't just surviving, it was pulsing, its brightness wobbling erratically as if gasping for breath. Spectrographic analysis revealed even more confusion. The star's outer layers were rich in heavy elements like calcium and titanium, the telltale signatures of a supernova's fury. Somehow, this star had endured the very explosion that should have erased it. Theories exploded faster than the supernova itself. One camp argued the star might be the original companion, scarred but not destroyed by the blast, its outer layers scorched away to reveal a helium-rich core. Others proposed something wilder: that the white dwarf didn't fully detonate, instead undergoing a partial supernova that left its core bruised but intact. The most radical suggestion: the explosion might have been triggered by two white dwarfs colliding, with one surviving the encounter like a cosmic prizefighter stumbling away from a car crash. What makes the zombie star more than just a celestial oddity is what it reveals about the messy, unpredictable nature of stellar death. For decades, supernovae were seen as tidy endpoints. Now, they might be just another chapter in a star's life, with some phoenixes rising from their own ashes. Whether it's a survivor, a failed explosion, or something entirely new, this cosmic Lazarus forces us to confront an exhilarating truth: even the universe's most violent endings might just be beginnings in disguise. If you could strip away the stars and galaxies, the universe would reveal its true skeleton: a vast, shimmering network of threads stretching across the cosmos like the veins of some unfathomable creature. This is the cosmic web, the hidden superstructure that binds everything together, and its filaments are the universe's most hauntingly beautiful secret. Made of dark matter and ionized gas, these tendrils weave through the void, connecting galaxy clusters in a delicate dance of gravity and time. You're looking at the blueprint of creation itself, the scaffolding upon which every star, every planet, every atom is hung. The scale is almost impossible to grasp. Individual filaments can span hundreds of millions of light years, yet they're so diffuse that mapping them required a revolution in astronomy. Scientists didn't just stumble upon this web, they predicted its existence decades before technology caught up. The clues came from the way galaxies move, as if tugged by invisible strings. Then, in the 21st century, supercomputer simulations finally rendered it: a labyrinth of dark matter, its gravitational pull funneling ordinary matter into glowing highways of gas. But the real breakthrough came when telescopes like the Hubble and the European Space Agency's Planck satellite captured the faint glow of hydrogen lit up by the radiation of ancient quasars, tracing these filaments like cosmic blacklights illuminating a spider's silk. What's astonishing isn't just the web's existence, it's how it shapes everything we see. Galaxies aren't scattered randomly, they cluster along these filaments like pearls on a necklace, drawn together by the gravitational tides of dark matter. Where filaments intersect, you find the universe's metropolis's colossal galaxy clusters like the Coma or Virgo superclusters, bustling hubs of stellar activity. But the filaments aren't just passive roads, they're pipelines ferrying gas from the emptiest voids to the hungriest galaxies. Without them, stars would lack the fuel to ignite and galaxies would starve in the darkness. Yet for all their importance, these filaments are nearly invisible. Dark matter doesn't emit light, and the gas threading through them is so hot it's ionized, missing the electrons needed to glow like a nebula. To see them, astronomers had to get creative. Some studied the way distant quasars' light dims as it passes through hydrogen fog in the filaments. Others mapped the subtle warping of space-time around them, using gravitational lensing as a cosmic magnifying glass. Each method revealed another piece of the puzzle, painting a picture of a universe far more connected than we ever imagined. The cosmic web isn't just structure, it's story. These filaments are fossil records of the universe's infancy, when quantum fluctuations in the aftermath of the Big Bang seeded tiny variations in density. Over billions of years, gravity amplified those wrinkles, sculpting them into the web we see today. In a very real sense, you're witnessing the universe's first stitches, the threads it used to knit itself together. And somewhere in that web, on an unremarkable filament in an ordinary supercluster, our Milky Way spins, a single leaf caught in a breeze that began 13.8 billion years ago. What's humbling is realizing this web is still growing, still evolving. New simulations suggest filaments may vibrate like guitar strings plucked by colliding galaxies, sending shockwaves through the intergalactic medium. Some researchers even speculate that dark energy, the mysterious force accelerating the universe's expansion, might one day tear this web apart, unraveling the very fabric that holds it all together. But for now, it stands as the universe's grandest design, a reminder that emptiness is an illusion. The cosmos isn't just full of wonders, it's woven from them. Black holes aren't supposed to hide, especially not in our cosmic backyard. Yet that's exactly what astronomers found in 2020 when they stumbled upon the unicorn, a black hole so small, so sneaky. It had been lurking just 1,500 light-years away, tucked inside a seemingly ordinary star system. At just 3 times the mass of our Sun, this pint-sized predator defies expectations, proving that even the universe's most voracious monsters can come in deceptively tiny packages. The unicorn's discovery reads like a cosmic detective story. For years, scientists had studied a red giant star called V723 Monocerotes, noting its strange behavior. Its light dimmed and brightened rhythmically, as if an invisible dancer were tugging it in an endless waltz. But when researchers crunched the numbers, they realized no star could explain the gravitational pull. The culprit had to be something darker, denser, and far more exotic, a black hole too small to fit the usual molds. Most stellar mass black holes we found weigh at least 5 solar masses, the remnants of colossal stars that collapsed under their own gravity. The unicorn, by contrast, might be the ghost of a star that barely crossed the threshold into black hole territory, leaving behind a compact shadow barely wider than Manhattan. What makes this discovery so groundbreaking isn't just the black hole's size, it's how it was found. Unlike its famous cousins like Cygnus X1, which reveal themselves by devouring gas and belching X-rays, the unicorn is dormant. It's not feeding, not flaring, just drifting silently beside its stellar companion, its presence betrayed only by the subtle wobble it imposes on the star's motion. This gravitational tug method opens a new chapter in black hole hunting. suggesting countless others might be hiding in plain sight, masquerading as binary star systems. The implications are staggering. If the unicorn isn't a fluke, our galaxy could be teeming with similar black holes, tens of thousands, maybe even millions, woven invisibly into the fabric of nearby star systems. Some might be even smaller, hovering near the theoretical edge of what can collapse into a singularity. Others could be drifting alone, undetectable unless they pass in front of a distant star and warp its light like a lens. The challenge now is finding them, and new telescopes like the Vera Rubin Observatory are poised to scan the skies for these subtle gravitational footprints. But the unicorn's greatest gift might be the questions it forces us to ask. How do stars so small become black holes? Could some be primordial, forged in the chaos of the early universe? And if black holes this tiny exist, what else have we missed? Every invisible monster we uncover rewrites the rules, proving that even in the cosmos we call home, the darkest secrets are often the closest ones. At the edge of the observable universe, where the light we see has traveled nearly 13 billion years to reach us, lies an object so baffling it shouldn't exist. Oumuamua J1342 plus 0928, the most distant quasar ever discovered. This cosmic beacon, shining from just 690 million years after the Big Bang, defies everything we know about how the universe grew up at its heart. A supermassive black hole weighing in at 800 million times the mass of our Sun, a monster that somehow feasted its way to maturity before the cosmos had even finished its morning coffee. To grasp just how impossible this quasar is, let's rewind the cosmic clock. The early universe was a dark, soupy mess, no stars, no galaxies, just a fog of hydrogen gas slowly cooling after the Big Bang's fireball. It took hundreds of millions of years for gravity to sculpt the first stars, then more time still for those stars to cluster into galaxies. Black holes, even the supermassive ones we find today, should have taken billions of years to grow. Yet here's Oumuamua J1342 plus 0928, its black hole already fully formed when the universe was less than 5% its current age. It's like finding a skyscraper in the middle of the Stone Age, an architectural marvel with no blueprints to explain its existence. So how did this black hole get so big so fast? The leading theory is a cosmic shortcut. Instead of growing steadily by swallowing gas and stars, it might have gorged itself in a frenzy of mergers where smaller black holes collided and combined over and over. Picture a snowball rolling downhill, gathering mass with every revolution, except here, the snowball is a singularity and the hill is the fabric of space-time itself. Some models suggest these early black holes could have fed at rates far beyond what's possible today, sucking in matter with terrifying efficiency in an era when the universe was denser, hotter, and ripe for chaos. But there's another, even wilder possibility that some black holes were simply born big. In the primordial universe where densities fluctuated wildly, pockets of gas might have collapsed directly into black holes without ever forming stars first. These direct collapse black holes could have started life thousands of times more massive than the ones formed from dying stars, giving them a head start in the race to become supermassive. It's a concept that turns stellar evolution on its head, suggesting the cosmos had a secret recipe for crafting giants right out of the gate. What makes Oumuamua J1342 plus 0928 more than just a record breaker is the light it sheds, literally. As the brightest object in the early universe, its radiation acts like a backlight, illuminating the hydrogen fog around it and revealing the moment when the first starlight pierced the cosmic darkness. This epoch, called reionization, was when the universe switched on its lights for good, and this quasar's glow gives us a front-row seat to the dawn of everything. Yet for all its brilliance, the real lesson of this impossible quasar is humility. Every time we think we've figured out the universe's rulebook, it throws us a curveball, a black hole too early, a galaxy too mature, a structure too vast. These outliers aren't just exceptions, they're signposts pointing to gaps in our understanding, hints that the cosmos might have shortcuts, backdoors, or entire chapters we've yet to discover. And somewhere out there, beyond the reach of our telescopes, more impossibilities are waiting, ready to rewrite the story all over again. Moons are supposed to be small, quiet companions, tiny worlds tethered to their planets like cosmic afterthoughts. Then there's Kepler 1625b, the first potential exomoon ever detected, and it shatters every expectation. This candidate, lurking in a distant star system 2,000 light-years away, isn't just large, it's planetary in scale, dwarfing every moon in our solar system with a size comparable to Neptune. If confirmed, it wouldn't just rewrite the rules of celestial mechanics, it would force us to rethink how moons are even born. The hunt for exomoons has always been a needle in a haystack challenge. Planets are hard enough to spot as they transit their stars, causing tiny dips in brightness. Moons, their signals are whispers buried in noise. But when astronomers analyzed data from NASA's Kepler Space Telescope, they noticed something peculiar about the gas giant Kepler 1625b. Its light curves had strange, asymmetrical wobbles like a planet not just dimming its star's light, but doing so with an invisible companion tugging at its orbit. The implications were staggering. A moon so massive, its gravitational influence could be measured across interstellar space. What makes this candidate so bizarre is its sheer improbability. In our solar system, moons form one of two ways. Either they're chunks of debris captured during a planet's chaotic early years, like Mars's lumpy satellites, or they coalesce from the same disk of material as their host planet, like Earth's orderly moon. But Kepler 1625b defies both models. At an estimated mass and radius close to Neptune's, it's far too big to be a captured object. The energy required to break something that massive into orbit would tear it apart. Yet it's also too large to have formed in situ. No known protoplanetary disk could birth a moon of that scale without collapsing into a binary planet system instead. The leading theory, a cosmic robbery. This might be the remnant core of a gas giant, stripped of its atmosphere during a violent encounter and left orbiting its conqueror like a trophy. Detecting it pushed technology to the brink. After the initial Kepler hints, astronomers trained the Hubble Space Telescope on the system, watching for subtle timing variations in the planet's transits, the telltale signature of a moon's gravitational dance. They even analyzed light distortions caused by the moon's hypothetical atmosphere, a technique so precise it borders on science fiction, yet confirmation remains elusive. The data teases but doesn't conclusively prove the moon's existence, leaving the astronomy community divided. Some argue the anomalies could stem from stellar activity or instrument artifacts, while others see a groundbreaking discovery waiting to be validated. Beyond the technical drama, Kepler 1625b represents something profound, a challenge to our cosmic provincialism. We assume our solar system's architecture is typical, that moons are modest and planets dominant. But what if we're the outliers? What if, in the broader galaxy, moons swell to sizes that blur the line between satellite and planet, rewriting the hierarchies we take for granted? Every flicker of data from this distant system whispers a tantalizing possibility that the universe's rulebook is far stranger and far more imaginative than we ever dreamed. Whether this candidate is ultimately confirmed or debunked, it's already done its job, proving that even the humblest celestial objects can defy our expectations in the most spectacular ways. Sometimes the universe doesn't just give us clues, it hands us a smoking gun. That's exactly what happened in 2004 when astronomers trained their telescopes on a cosmic collision so violent, it didn't just reveal dark matter, it photographed it. Meet 1E0657-56, better known as the Bullet Cluster, a pair of galaxy clusters caught in the aftermath of a head-on wreck at over 47 million miles per hour. What makes this collision special isn't the carnage of stars and gas, it's the invisible wreckage left behind, the clearest evidence yet that dark matter isn't just theoretical. It's real, and it's shaping the cosmos right before our eyes. The setup sounds simple enough. Two galaxy clusters, each thousands of galaxies strong, plowing through one another like freight trains in the night. But the magic lies in what happens, or rather, what doesn't happen, to their components. When clusters collide, their hot gas clouds packed with ordinary matter slam together and slow down like cars in a traffic jam, glowing brightly in X-rays. The stars, meanwhile, mostly sail right past one another, too spread out to crash. But dark matter, it doesn't play by either rule. Here's where Einstein's genius comes in. Dark matter doesn't emit light, but it does warp spacetime with its gravity, and that's how astronomers saw it. Using gravitational lensing, they mapped the cluster's mass by measuring how its gravity bent the light of more distant galaxies behind it. The result was staggering: two huge clumps of mass dark matter, floating ahead of the gas, completely detached. It was proof that dark matter doesn't interact with ordinary matter or even itself during collisions. It just keeps going, like a ghost walking through walls. This wasn't just a breakthrough, it was a demolition of competing theories. Some scientists had argued that dark matter might not exist at all, that gravity itself behaves differently on cosmic scales. But the bullet cluster shut that door. If modified gravity were true, the lensing effect would have followed the gas, not the unseen mass. Instead, the dark matter sailed ahead, leaving the gas in its wake, a behavior only possible if it's a thing, a substance with real heft but no stickiness. Yet the bullet cluster isn't just about proving dark matter exists, it's about showing how it moves. The way the dark matter outpaced the gas suggests it's collisionless, a property that helps explain why galaxies don't fly apart. Dark matter forms invisible scaffolds, holding spinning galaxies together even as their stars whirl at speeds that should fling them into the void. Without it, our Milky Way would have unraveled billions of years ago. The irony: this cosmic wreckage, this chaos of gas and gravity, might be the most orderly evidence we've ever gotten. It's a snapshot of the invisible skeleton of the universe, a reminder that what we can't see is often what matters most. And somewhere out there, other collisions are unfolding, each one a potential Rosetta Stone for decoding the dark universe's deepest secrets. The bullet cluster didn't just give us answers, it taught us how to ask better questions. Most planets have a home, a star to orbit, a rhythm of days and years defined by light and warmth. Not CFBD Sir 2149-0403. This lonely wanderer drifts through the void without a sun, untethered by gravity, a rogue planet condemned to eternal night. Discovered in 2012, this free-floating world is one of the rarest anomalies in the cosmos, a place where the sky is forever black, where the only heat comes from the radioactive decay deep in its core, and where the concept of a sunset is nothing but a distant fantasy. At first glance, CFBD Sir 2149-0403 seems like a cosmic mistake. Planets aren't supposed to exist like this, cast adrift, orphaned from the systems that birthed them. But the truth is even stranger. This rogue world likely did form around a star, only to be violently ejected in its youth, flung into the abyss by a gravitational slingshot from a passing giant or a chaotic dance of sibling planets. Picture a game of cosmic billiards where a single miscalculation sends a world careening into the darkness forever. What's truly chilling is imagining its surface. With no star to warm it, temperatures hover around 400 degrees below zero, cold enough to freeze oxygen solid. Its atmosphere, if it has one, would be a suffocating blanket of methane and water vapor, swirling in endless storms with no sunlight to power them. And yet, against all odds, this planet might not be entirely lifeless. Some models suggest rogue planets could retain subterranean oceans, heated by radioactive decay or tidal friction, hidden beneath miles of ice. If microbes exist in the crushing depths of Earth's oceans, why not here in the eternal night of interstellar space? But the real mystery isn't just how this planet got here, it's how many more are out there. Astronomers suspect rogue planets may outnumber stars in the Milky Way, a hidden population of drifters flitting between the light. Some could be frozen wastelands like CFBD SIR 2149-0403, while others might be steamy water worlds, their surfaces sealed beneath global ice sheets. A few could even be Earth-sized, ejected from their systems by some ancient catastrophe and left to wander the galaxy alone. The sheer loneliness of this existence is hard to fathom. No sunrise, no seasons, no neighboring planets, just an endless journey through the dark, with only the distant glow of the Milky Way for company. Yet in that isolation lies a kind of freedom. While most planets are prisoners to their star's gravity, this rogue is utterly untethered, a sovereign world answering to no one. Perhaps that's the most haunting lesson of CFBD SIR 2149-0403. The universe doesn't just build orderly systems, it creates exiles, strays, and rebels, rewriting the rules of what a planet can be. And somewhere out there, in the cold and the quiet, this lonely giant is still drifting, a silent testament to the chaos that shapes the cosmos. In the vast cosmic menagerie of galaxies, most are majestic spirals or hulking ellipticals, but a handful stand out like glowing emerald jewels scattered across the darkness. Meet the green pea galaxies, tiny cosmic anomalies no bigger than a tenth of the Milky Way, yet burning with such ferocious star formation they shine with an otherworldly green hue. Their discovery reads like a happy accident in 2009. Citizen scientists combing through Galaxy Zoo project data tagged a few peculiar galaxies as green peas for their small, round shapes and vivid coloration. Astronomers quickly realized these weren't just oddities, they were windows into the universe's wild youth. What makes these galaxies glow isn't just their color, it's their chemistry. The intense emerald light comes from doubly ionized oxygen, a fingerprint of gas being blasted by ultraviolet radiation from newborn stars. Unlike mature galaxies where star formation is a slow simmer, green peas are cosmic pressure cookers, churning out stars at rates 10 times faster than the Milky Way relative to their size. Imagine a firework factory crammed into a closet. That's the level of explosive energy packed into these petite powerhouses. Their interstellar gas is pristine, barely touched by the heavier elements forged in previous generations of stars, making them chemical time capsules from an era when the universe itself was in its infancy. The real revelation: green peas might be the closest modern analogues to the galaxies that flooded the young universe with its first light. During the epoch of reionization, when the cosmos transitioned from a dark hydrogen fog to a transparent, star-lit expanse, small, energetic galaxies like these are thought to have been the primary torches, their fierce radiation ionizing the surrounding gas. While most galaxies from that era are too distant to study in detail, green peas offer a rare local lab to test these theories. Their oxygen emission lines match those seen in high redshift galaxies, suggesting the same physical processes are at work, just scaled down to a cosmic petri dish we can observe up close. Yet for all their brilliance, green peas raise thorny questions. How can such tiny galaxies sustain such extreme star formation without blowing themselves apart? Their stellar nurseries defy the typical limits of feedback, where supernova and stellar winds usually regulate star birth by dispersing gas. One clue lies in their leaky nature. Observations suggest these galaxies can't fully contain their own radiation, allowing energy to escape rather than quenching future star formation. It's as if they've found a loophole in the laws of astrophysics, a way to stay perpetually in overdrive while other galaxies exhaust themselves. The most tantalizing possibility is that green peas might hold secrets about the origins of life itself. Their rampant star formation produces copious ultraviolet light, the same kind thought to have helped kickstart organic chemistry in the early universe. Some researchers speculate these galaxies could be seeding their surroundings with the building blocks of life, their radiation acting as a cosmic catalyst for molecules that might one day form planets and perhaps even living things. In a universe where bigness often steals the spotlight, green peas remind us that sometimes the smallest objects pack the biggest surprises. They're not just galactic oddballs, they're living fossils, glowing green messengers from a time when the cosmos was new. And as astronomers continue to study them, these unassuming little galaxies may yet reveal how the universe turned on its lights and why, in the grand tapestry of creation, size isn't everything. Deep in the heart of the Milky Way, hidden among the glittering crowds of younger stars, something unexpected stirs. An elderly red giant star, long past its prime, suddenly convulses and coughs out a thick, dark cloud unlike anything astronomers have ever seen. Meet the old smokers, a newly discovered class of geriatric stars that spend decades, sometimes centuries, quietly fading into obscurity, only to erupt without warning, belching vast plumes of dust so dense they completely vanish from view for years at a time. These aren't the violent outbursts of supernova or the predictable pulses of variable stars. They're something far stranger, the cosmic equivalent of a sleeping volcano rumbling back to life when no one was watching. The discovery unfolded like a celestial detective story. For years, surveys scanning the galactic center kept noting mysterious stars that would dim dramatically over months, their light fading by as much as 99%. At first, researchers assumed these were typical eclipsing binary systems where one star passes in front of another. But when they looked closer, the truth was far more peculiar. These weren't young stars being periodically shadowed, they were ancient red giants, stars in their final evolutionary stages, shrouding themselves in self-made veils of carbon-rich dust. Even stranger, the dimming events weren't periodic. A star might vanish for a decade, suddenly reappear, then fade again 50 years later with no discernible pattern. It was as if the universe had hidden an entire population of stellar retirees with bizarre, unpredictable habits. What's truly groundbreaking about these dusty eruptions isn't just their unpredictability, it's what's in the smoke. Spectroscopic analysis reveals these clouds are packed with complex organic molecules, including carbon chains and polycyclic aromatic hydrocarbons (PAH), the same building blocks that on Earth form the basis of life. Here's where things get cosmic. When these old stars cough, they don't just expel material, they seed it. The dust clouds, propelled by stellar winds, eventually disperse into interstellar space, carrying their chemical cargo across the galaxy. Over millennia, these molecules could hitch rides on comets, asteroids, or protoplanetary disks, potentially delivering life's raw materials to newborn worlds. The million-dollar question, why now? Red giants aren't supposed to behave this way. Conventional models suggest they lose mass steadily through gentle winds, not in violent, opaque fits. One theory points to instabilities in their outer layers as these stars burn through their final fuel. Their cores contract while their outer atmospheres swell to monstrous proportions, creating conditions ripe for sudden collapses and eruptions. Another idea involves binary companions, perhaps unseen neighbors. White dwarfs or neutron stars gravitationally tug material away until the star reaches a tipping point, triggering explosive dust production. But the most tantalizing possibility is that we're witnessing a previously overlooked phase of stellar evolution, one where dying stars play chemist, brewing complex organics in their outer layers before blasting them into the void. If true, old smokers might be far more than curiosities. They could be galactic alchemists, quietly enriching the cosmos with the ingredients for life, one smoky outburst at a time. And in the crowded stellar nurseries of the Milky Way's core, where stars are born surrounded by such debris, their contribution might be the silent spark that makes all the difference. What lingers after each eruption isn't just dust, it's possibility. These stars remind us that even in death, celestial objects can nurture new beginnings, their final act scattering seeds across the cosmos. And somewhere in that expelled smoke, among the swirling carbon chains and organic haze, might lie the untold prologue to a story we're only beginning to understand, one where the oldest actors in the galaxy hold the keys to life's origins. Out of all the cosmic mysteries, none is more profound or more unsettling than the one we can't even see. The Fermi paradox isn't an object, a signal, or a celestial oddity. It's an absence, a silence, a question that's haunted astronomers since the day Enrico Fermi first stared into the night sky and asked, "Where is everybody?" Consider the numbers. Our galaxy alone holds hundreds of billions of stars, many with planets in the so-called Goldilocks zone, neither too hot nor too cold for life as we know it. The universe has existed for 13.8 billion years, plenty of time for civilizations to rise, spread, and leave their mark, and yet nothing. No radio signals, no megastructures, no alien probes drifting through our solar system. Just an endless, indifferent quiet. This isn't just puzzling, it's unnerving. So where are they? Theories abound, each more mind-bending than the last. The zoo hypothesis suggests we're being deliberately ignored, that advanced civilizations observe us like animals in a cosmic nature preserve, withholding contact until we reach some undefined maturity. Then there's the dark forest theory, borrowed from sci-fi but rooted in grim logic. Perhaps every civilization stays silent out of fear, knowing that announcing your presence might invite destruction from a hostile universe. Others argue the answer lies in sheer rarity. The rare Earth hypothesis posits that while microbial life might be common, the chain of events needed for complex life, stable orbits, plate tectonics, a protective moon, is so improbable we might truly be alone. Or worse, the Great Filter theory warns that some catastrophic barrier, nuclear war, runaway AI, environmental collapse waits to wipe out all intelligent life before it can colonize the stars. Maybe every civilization hits this wall and none survive long enough to say hello. But here's the twist: the paradox might be an illusion. Our search has barely begun. We've scanned a fraction of 1% of our galaxy, and our methods are crude. Alien communication might use neutrino beams or quantum entanglement, technologies we can't yet detect. Or perhaps civilizations transcend biology, merging into digital consciousness or abandoning the physical universe entirely, leaving no trace for primitive eyes like ours to find. The most humbling possibility: we're early, the universe is young, and we might be among its first children. The stars are still here, the resources still untouched. The silence isn't a warning, it's an invitation. The cosmos is waiting, not for answers, but for us to ask the right questions. And in that silence, there's not just mystery, but possibility. After all, if we are alone, that makes us something rarer than any diamond planet or rogue black hole, the universe's only voice, its only breath, its only chance to know itself. So the next time you look up at the stars, remember, the greatest enigma isn't what's out there. It's why, in all that immensity, we've only ever heard our own echo. And whether that's a tragedy or a triumph, well, that's up to us to decide. Oumuamua's greatest mystery wasn't just its shape or its origin, it was the way it moved. As the interstellar visitor sped away from our sun, something impossible happened. It accelerated, not in the smooth arc gravity demands, but in fits and starts, as if pushed by an unseen hand. This wasn't just unusual, it was unprecedented. Natural objects don't behave this way unless something's propelling them. And that's where the scientific community split into warring camps, each armed with competing papers and radically different visions of what Oumuamua truly was. On one side stood the conventionalists, scrambling to explain the acceleration without invoking aliens. Their leading theory: hydrogen outgassing. Imagine an iceberg, but instead of water, it's frozen hydrogen, a hydrogen iceberg forged in the cold depths of interstellar space. As Oumuamua neared the sun, the theory goes solar radiation vaporized its surface, releasing invisible hydrogen jets that acted like natural thrusters. No tail, no visible outgassing, just enough gentle nudges to explain the speed boost. Supporting this, researchers pointed to similar behavior in solar system comets, where volatile ices like carbon monoxide can produce unseen jets. If Oumuamua was a hydrogen iceberg, it would also explain the object's bizarre shape. Hydrogen's low sublimation temperature might have sculpted it into that elongated cigar form over eons of cosmic erosion. But Harvard astrophysicist Avi Loeb wasn't convinced. Hydrogen icebergs, he argued, shouldn't survive the journey. Interstellar space is bathed in cosmic rays, which would break apart a hydrogen-rich object long before it reached us. Instead, Loeb proposed something far more radical. Oumuamua wasn't a natural object at all, but a piece of alien technology, a light sail. These theoretical structures, thin and reflective, harness radiation pressure for propulsion, exactly as Oumuamua seemed to. Its unusual brightness variations could be explained by a tumbling sail's alternating faces catching sunlight, while its trajectory matched what you'd expect from an object designed to coast between stars. The clincher, the acceleration's precision. Outgassing tends to be messy, yet Oumuamua's speed changes were eerily consistent, as if finely tuned. The debate raged beyond academia, spilling into public discourse with a volatility rarely seen in astronomy. Critics accused Loeb of sensationalism, arguing that extraordinary claims demand extraordinary evidence, and a single odd object wasn't enough. Others countered that science should follow the evidence, however uncomfortable. The truth is, both sides faced gaps. Hydrogen outgassing couldn't fully explain Oumuamua's reflectivity, which was far higher than any known comet. Meanwhile, the light sail theory struggled with the object's apparent lack of radio signals or deliberate course changes. What makes this controversy so pivotal isn't just the question of Oumuamua's identity, it's the way it exposes our biases. We're quick to assume natural explanations, even when they require stretching known physics, while dismissing extraterrestrial possibilities as fringe. But as Loeb himself often asks, if not Oumuamua, then what would convince us? The next interstellar visitor, already spotted in 2019, behaved like a typical comet, underscoring just how anomalous Oumuamua truly was. Maybe it was a hydrogen iceberg, maybe it was a fragment of an alien probe, or maybe, and this is the most thrilling possibility, it was something else entirely, a phenomenon we haven't yet imagined. The universe rarely gives us easy answers. Oumuamua's fleeting visit forced us to confront the limits of our knowledge, to weigh the improbable against the impossible. Whether it was nature's prank or a postcard from another civilization, one thing's certain: the next time an interstellar stranger knocks on our door, we'll be watching and arguing closer than ever. From diamond planets to galactic cannibals, rogue wanderers to cosmic smoke rings, we've toured a universe so strange it feels ripped from the pages of a sci-fi novel. Yet here's the wildest part: every one of these 25 objects is real, each one a reminder that reality outshines imagination. The cosmos doesn't just contain mysteries, it is a vast, glittering puzzle where the pieces keep changing shape the moment we think we've figured them out. Consider what ties these oddities together. It's not just their strangeness, it's how they expose the gaps in our understanding. The Black Knight's legend versus its likely mundane truth. The wow signal's haunting one-time cry, the Great Attractor's invisible pull, and the Boötes Void's unnatural emptiness. These aren't just curiosities, they're cosmic breadcrumbs, leading us toward questions we haven't even learned to ask yet. And that's the thrill. For every mystery solved, a dozen more emerge, each more baffling than the last. What's your pick for the most mind-bending entry? A pulsar's diamond worlds, the old smoker's organic belches, or maybe the dark flow's suggestion of realms beyond our horizon? Drop your favorites in the comments. We're all cosmic detectives here, piecing together the universe's greatest hits of weirdness. And if this journey left you hungry for more, you're in luck. The universe never runs out of enigmas, and neither do we. Hit subscribe to join us for the next adventure, where we'll dive deeper into the unknown, one celestial head scratcher at a time. Because here's the ultimate truth: the universe isn't just stranger than we imagine, it's stranger than we can imagine, and that's what makes exploration so exhilarating. The more we discover, the clearer it becomes we're just getting started.